there, Algebras. Welcome to our Chapter 7 Lessons 1 through 3 review. Now, in your packet, I just want to point out there is both a Chapter 7 Lessons 1 through 3 review and a Chapter 7 quiz review. These are the same thing. They are reviewing the same things, okay? And it is all lessons 1 through 3. I want to go over a little bit of both, okay? I do want to start with the quiz review. And the reason I want to start with the quiz review is because it divides into each lesson. So our directions divide us into the type of factoring we are supposed to be doing in each of the sections, okay? So here we are greatest common factoring. Here we are difference of two perfect squares factoring. And here we are factoring trinomials into two binomials, okay? So this is the reason I really want to start here, so I can point out a few special pieces, and then we can go back here and see them in mixed review form. Okay, so we can point out the differences. So let me start with GCF, okay? GCF stands for greatest common factor for factoring. We are looking at our two terms or our three terms and trying to find what is something that's in common between them that can be divided out. And then in the parenthesis behind, I'm going to leave a leftover. Okay? Let me start with number one, where there are two terms. So that means I look at both terms and I say, well, what are you both evenly divisible by? They both are evenly divisible by 2. They happen to both be even. So 2 is my common factor. Is there a t in both of these terms? No. So t is not a common factor. So now that I've got my GCF out here, I make an empty set of parentheses behind it, able to fit two pieces, because each of these pieces is now going to divide by 2. What's 2t divided by 2? It's 1t, or just t. What's 2 divided by 2? It's plus 1. And that's your leftover. GCF, leftover. Let's do that again. This time we got 3 terms here, right? 1, 2, 3 terms, a trinomial, but I know I'm GCF factoring. So I'm looking for what do all 3 terms have in common? And all 3 terms have a 5. They're all evenly divisible by 5. And all 3 terms are able to be divided by a single x. And the reason I know that is because this last term, the x exponent is only 1, and that is the lowest I have. So that's the most number of x's I can bring out of all present terms. So 5x is my GCF, and now I make an empty set of parentheses big enough to hold trinomial as an answer. And now I do dividing by each term. 5x cubed divided by 5x. Well, 5 divided by 5 cancels to a 1. X cubed divided by x, that's an x squared. So 1x squared, or just an x squared, remains. 15x squared divided by 5x. Well, 15 divided by 5 is plus 3. X squared divided by x, well, that would leave an x to the first, or 3x in its wake. Last but certainly not least, negative 10x divided by 5x. Well, x over x cancels out to a 1. So really just my number will remain. Negative 10 divided by 5 is negative 2. There is your leftover with the GCF of 5x. Okay? Let's keep going with that. Let's look at a couple others. So I'll do a few more and then leave you to try a few of them, right? So number 5, ry plus 5y. What did I say in both terms? Y. There is not a number in common in both terms. So the y is the only GCF. I make an empty set of parentheses afterwards to be able to fit the binomial answer, right? Now, ry divided by y, well, the y's cancel out to a 1, only an r is left. 5y divided by y, the y's cancel out to a 1, only a plus 5 is left. See that common term, right? See that common term on number 6? What do they all have in common? A 9. That's the greatest common factor. Then leave an empty set of parentheses big enough for a trinomial answer. 9x divided by 9. Well, that's a 1x or just an x. Negative 9y divided by 9. Well, that's a negative 1y or just a negative y. Negative 9z divided by 9. Well, that's a negative 1z or just a negative z. You don't have to write that 1 when it's a 1 term, but you do have to get that sign correct. Okay? Let's look at another one. How about number 10, where they've all got a G? See that? They've all got at least one G. So that means a G will be part of my GCF. And then let's look at the numbers, 7 and 49 and negative 28. Well, they're all divisible by 7. So then make a binomial, or excuse me, an empty set of parentheses big enough for a trinomial answer. 7g divided by itself, any number divided by itself is 1. So we leave a positive 1 here. Okay, always. Nothing's going to divide to give me 0. 49g squared divided by 7g. Well, 49 divided by 7 is 7, positive 7. G squared divided by g is a g. Negative 28, g cubed. Well, negative 28 divided by 7 is negative 4. G cubed divided by g is g squared. Sorry that I'm a little squishy there. Okay, negative 4g squared is left back there. Ooh, 11 is great because pi is a constant and it is in both terms. So what are both terms evenly divisible by? There's a 3 factor in both, there's a pi factor in both, and there's an r factor in both. So let's pull it all out, right? 3 pi r is our GCF. Then leave enough room for a binomial as a leftover. 3 cancels out to a 1. Pi's divide and cancel out to a 1. R squared divided by r, just a 1r remains. Negative 6 divided by 3 is negative 2. The pi's cancel out to a 1. The r's cancel out to a 1. 1 times negative 2. I just write down that negative 2 because it's kind of absorbed the ones that were from the canceling. Okay, why don't you pause right here, okay, try a couple of GCFs, and then move on to the dots, the difference of two perfect squares, okay? Pause right here, try them out, then restart. Okay, so now let's try to look at some difference of two squares factoring, right? So when we look for difference of two squares, we need to only have binomials, meaning only two terms. They have to have subtraction between them. That's the difference part of difference of two squares. And each thing has to be perfect squares. So that's how, if I don't have directions that specifically say factor dots or factor difference of two perfect squares, I know how to factor these pieces. Okay, that's what I'm always on the lookout for. Notice every one of these has a minus sign between them. They're only binomials, and all of my variables have even exponents on them, and all of the values, the numbers attached, any coefficients, they're all perfect squares. So let me get into some of the more challenging, potentially ones. If you don't have your perfect squares memorized, you got to make sure you do. Okay. Let me get into like number 16, for example. 81 and m to the 8th, they're a perfect square. 289 and n to the 6th, perfect square, and I'm subtracting them. So when I see a perfect square minus a perfect square, and I'm asked to factor it, I immediately make 2 empty sets of parentheses for binomials to go in. Now I look at the front term, and I take its square root. The square root of 81 is 9, goes in the fronts of both binomials. The square root of m to the 8th is m to the 4th, goes in the fronts of both binomials. That's one term attached. Now I go to the back and take the perfect square. Square root of 289 is 17. I didn't, oh, you know what? Let me make myself a little more room because these were big terms that I have here. (17) and n cubed, right? Square root of n to the sixth is n cubed, and now different signs between them. Always a plus or minus in each of the binomials. Does it matter the order? No. Again, commutative property. Okay, let's try another one. How about number 17? A to the fourth minus 4b squared. A to the fourth is a perfect square, 4b squared is a perfect square, and I'm subtracting them. This factors by difference of two perfect squares. I'll make my binomials a little bigger this time. Start with the front term. What's the square root of a to the fourth? A squared goes in the fronts of both binomials. What's the square root of 4b squared? 2b goes in the backs of both binomials. And then different signs between them. If ever you need to check, FOIL. Pretty much one of the most basic ones, number 24, right? X squared minus y squared. Perfect square minus perfect square, always factors to become two binomials. Square root of the front term, square root of x squared is x. Square root of the back term, square root of y squared is y, and different signs between them. If that has numbers in front, right? So this is basically the same problem, just with a 25 in front of the x squared and a 16 in front of the y squared. Perfect squares and subtraction between them. So empty sets of parentheses, the square root of 25x squared is 5x in the fronts. The square root of 16y squared is 4y in the backs, and different signs between them. Okay, that's exactly how you handle it. You want to make sure you are checking a perfect square minus a perfect square. Let me try number 20, because sometimes you'll run into this where, yeah, it's not in standard form, but it's still a perfect square minus a perfect square, so it still factors exactly the same way. Make your empty sets of parentheses, and square root of 256 is 16 in the fronts. Square root of f squared is f in the backs, and different signs between them. Okay, and you do want that in that order because of this minus piece. Okay, those have to have those signs to get those signs in the end when you are multiplying out by FOIL. Okay, again, pause, take some time, try some of these, check it against the answer key that I'll have posted, but this always factors the same way. Okay, every single time. Just get that pattern in your head, get those perfect squares in your head. Even exponents on variables, those are perfect squares. All right, pause it here, try a couple, and then move forward. Okay. All right, so the last piece for review is factoring trinomials into two binomials, right? So again, these factor a specific way. There is a specific thought process you want, and that is what multiplies together to give me the end number, but adds or subtracts to give me the middle number. Okay, now I'll start with these two, okay, because they give me a good jumping point to talk about sign usage. All right, so number 27. Remember, check for the variable being used. It's p in this case, it's not an x. So think about what times what gave me p squared. It was p times p. So those go in the fronts of my two binomials. Now that end term, that's the one you want to think, what multiplies together to give me 18? So if you want to write it down, you can, but your options are 1 and 18, 2 and 9, 3 and 6. So you think about the sign on the end term, and that's a positive 18. And if this is a positive, that means these are adding to get the middle number. That means they're going to be the same signs inside your binomials. Okay, we're adding to get the middle. So which of those combos is going to add to give me 11? 1 and 18 is 17. 2 and 9 is 11. 3 and 6 is 9. So 2 and 9 is my combo that adds up to 11. So those are going to be the numbers inside the binomial. Again, doesn't matter the order I write these binomials. But what does matter is the signs that these numbers get. If 18 is positive, so if your end number is positive, you know these have the same sign. And the bigger factor always has the same sign as the middle. So guess what? 9 has to be positive, which since these have to have the same sign means 2 also has to be positive. So plus in both binomials. Now, when your end term is negative, that's when you're subtracting to get your middle value. Okay? And then that's when your binomials have different signs in them. So let's think about what multiplies together to give me 12. There's 1 and 12, always 1 in itself. That's always my first one. There's 2 and 6, and there's 3 and 4. Okay? And now, because that 12 in the back is negative, I am subtracting to get this -1. Won't be written in, but I'm writing it in for you to think about it right now. So I'm subtracting to get that -1, okay? So let me put my x's in the front because this x squared comes from x times x. Now, 12 minus 1 is 11. 6 minus 2 is 4. 4 minus 3 is 1. How can that 1 be negative? So 4 and 3 are my numbers then, okay? But how can that 1 be negative? Well, the bigger factor always has the same sign as the middle for this reason. What's bigger, a 4 or a 3? Right. So the 4 has to have the same sign as the middle. That's where your minus is. Now, because the end term is negative, these are different signs. So what does that leave the 3 to be? A positive. That's how they would FOIL and give you a -4x, a positive 3x. That adds up to -1x when you're FOILing out for your trinomial and combining your like terms. That's where you want to be on the lookout. Okay, that's where you really need to kind of watch what you're doing for your signs. So again, number 29 is negative. It's 30 at the end. So you got 1 and 30, 2 and 15, 3 and 10, 5 and 6, right? As your potential pairs for factors. Now, because 30 is negative, we are subtracting to get that middle number. So let's do some subtracting and think about who's going to subtract to give me 7, right? So 1 and 30 subtract to give me 29. 15 and 2 subtract to give me 13. 10 and 3 subtract to give me 7. So starts with an N, so N's in the fronts. 7. Oh, I keep saying it. Just turn that into a 3. Oh, that's an awkward looking 3, sorry. 3 and 10 will subtract to give me 7 if the bigger factor, which is 10, has the same sign as the middle. Because your end term is negative, these are different signs, leaving your 3 to be positive. That's how you know. If your end term is positive, they'll be the same signs, and it will be the same sign as the middle. If you keep in mind that the bigger factor always has the same sign as the middle, you know what drives your signs in your binomials. So again, what multiplies together to give me 14? 1 and 14, 2 and 7. So what option will add up to 9 for your middle, right? Y is in the front. 2 and 7 will add to give me 9. Now, that bigger factor has to match the same sign as the middle. So that's got to be negative, but because your end number is positive, this is also having to be negative. They had to have the same sign to multiply together to give me a positive 14 at the end. All right? These aren't that hard when you really consider these sign rules when you're going through. Okay? Always remember that 1 in itself are factors. So when you run into something like 32, what are the only factors of 5? Because it's prime. 1 and 5. That's it. So you know that your options are only 1 and 5. And again, please watch what variable is being used in each case. Your only options are 1 and 5. What's the bigger factor? 5 has to have the same sign as the middle. And because your n number is positive, they both have the same sign. Okay, so really think about that stuff as you're going through. All right, and again, try some of these. Pause it, try them, give them a shot, practice. And then we're going to finally look at the chapter 1 through 3 review. Okay. All right, so we started out with the quiz review that had each section specifically telling you how to factor. But this just says factor in general. Could be GCF, could be dots, could be a trinomial and two binomials. And you have to make that determination. Here's the big secret for making that determination. If it's a trinomial and two binomials, it's the easiest. If you've got a trinomial, it will absolutely be two binomials and what multiplies together to give me the end that add or subtracts to give me the middle. Okay? That's the easy ones to do. If you've got a binomial, okay? If you've got a binomial, you have to look for, do I have a perfect square minus a perfect square? Okay, you have to look for that. So on number 1, x squared is a perfect square. Yes, I'm subtracting. 4 is a perfect square, but x to the first is not. This is GCF, okay? And that's what you're going to need to be on the lookout for, which is why you need to know your perfect squares. So that means there's only a GCF of x here. And now I divide each term by x. X squared divided by x is 1x. Negative 4x divided by x is negative 4. Now, what's the difference with number 2? Well, number 2 is a perfect square minus a perfect square. 9c squared is a perfect square. 9 is a perfect square. And I'm subtracting them. So this is dots. That's what you need to be on the lookout for. Okay? So we've got 9 that can come, taking difference, two perfect squares. I went back to GCF. Square root of 9c squared, 3c in the fronts, square root of 9 in the back, 3, plus and minus sign between them. There is a case for each of those having a GCF that you could pull out, but we'll talk about that in lesson 4. All right, so we're not quite there to factoring completely yet. But I do want to point out that a couple of these questions, a couple of these trinomials have a variable raised to the 4th power. What that means is when you're doing this binomial, trinomial into two binomials, you just start with the square root of that. So this just starts with an h squared, okay? Now we still do the same consideration. What times what gives me 12, but subtracts to give me 4? It's 6 and 2. The bigger factor always has the same sign as the middle, and since the n term is negative, that leaves me with a positive 2 there. Careful on number 11, this is not a perfect square. So there's a GCF there of z, and then you're left with z plus 25. So you have to be very careful. This is not a perfect square because Q is not a perfect square, because P is not a perfect square, because 20 is not a perfect square. That's not dots, that's GCF. And that's exactly what you look for. Whatever's left, that's GCF. Okay, these are great things to practice with. They really are. Okay, great things to practice with when you have to think about which factoring to do. If you're not there yet, just finish up with these guys in the quiz review. Okay, but this really gets your brain working about which type of factoring and how to distinguish between which type of factoring. Okay. Make sure you're practicing this before you're taking your quiz. Your quiz does tell you which type of factoring to use in each spot. So, I mean, I do make it a little easier for you. But in the future, you're going to have to make that distinguishing mark, like in lesson 4. Okay, so be ready for that. That's where this will really help out. Okay? I'll be seeing you guys soon for lesson 4. Good luck on that quiz. Bye.